All right, here we go. So if you have a number, if you're looking at number 34 in the review, okay, it reads, a bullet with a mass of 0.1 kilograms moving at 2.00 times 10 squared meters per second embeds itself into a block of wood with a mass of 3 kilograms. What is the final velocity of the bullet block combination? So really what we're looking at here is you're going to look at the momentum of the bullet before, okay, and then you are going to go ahead and analyze it striking the block of wood, and then what is the block and the bullet going to, how fast are they going to be moving afterwards. So to do this, you have to understand the fact that momentum is conserved, meaning that the momentum of the bullet before and the combo bullet block moving afterwards, the two momentums have to be exactly the same. So the momentum before equals the momentum after. So when we write that, okay, we write it kind of like this. So momentum before and momentum after. Okay, so we need to find the momentum before. To do this, what we do is we take the mass of the bullet times the velocity of the bullet. Okay, so really what we have is the mass of the bullet times the velocity of the bullet. Okay, the mass of the bullet is 0.100 kilograms. Okay, this translates to 0.100 kilograms, and you're going to be multiplying that by 2.00 times 10 squared meters per second, or 200 meters per second. Okay, if you take 0.1 and multiply it by 200, you get 20. So the momentum before is going to be equal to 20 kilograms times meters per second. Okay, and this momentum before has to be equal to the momentum after. So one of the things to kind of take into consideration here is that the momentum after is going to have to equal 20 kilograms times meters per second. The momentum after also equals the mass after times the velocity after. Okay, which means that you're going to take this momentum and you're going to compare it to the mass of the block bullet combination, and you're going to compare it to, and you're trying to find velocity. Okay, so really what this translates as is 20 kilograms per meters per second, and that's going to be equal to mass times velocity. Okay, so you have to change your mass and include the block. That's why they give you the mass of the block to be 3 kilograms. So if we go ahead and take all of that into consideration, we will see that 20 will be equal to 3.10 kilograms times some unknown velocity which we're trying to achieve. And if you take 20 and you divide it by 3.10, you get the final velocity. Which ends up being 6.45 meters per second. Okay. Now this kind of problem where you're taking the momentum before and the momentum after is the same in 35 and 36. You're basically finding momentum before, you're finding momentum after. So in 35 you have a cannon. Okay, and what it says is that everything starts at rest, which means that when it shoots, the cannon is going to recoil backwards, and the cannonball is going to be projected forwards, and the two momentums of those two objects have to be equal and opposite, so that when you add them, it's 0, like at the very beginning when they were at rest. So in this particular situation, we're going to go ahead and start by finding the momentum of the cannon moving backwards. To do this, the momentum of the cannon is going to be equal to the mass of the cannon, which is 900 kilograms, times the velocity of the cannon, which is 3 meters per second. And if you go ahead and multiply those two numbers out, 900 times 3, you should get 2,700. And that is your momentum that you're working with. Now, the cannonball has to have equal and opposite momentum, okay? Because the cannon is moving with positive velocity, the cannonball will have to be moving with negative velocity. Okay, so the momentum's not going to change. It's going to be 2,700. And if we take and we divide the mass of the cannonball into that number, we will get our velocity. Okay, so in order to find the velocity of the cannonball, we go ahead and take our total momentum and we divide it by the velocity of, or we divide it by the mass of the cannonball, which is 20 kilograms. So 2,700 divided by 20 gives us a grand total of 135 meters per second. Okay, but it has to be a negative 135 meters per second so that they're equal and opposite. So the answer to 35 is a negative 135 meters per second. .36 is very much the same, because this one's easier than the cannon and cannonball problem. Basically, what you're working with here is you're working with one football player who's running, and he gets tackled and stopped dead in his tracks by another football player, which means that their momentums have to be equal and opposite in order to, when they collide, be at rest. So if you take an 85 kilogram football player, which is a pretty heavy football player, by the way, and you multiply that by 8.70 meters per second, which is that football player's velocity, you end up with roughly 739.5 as your momentum. If you divide that momentum then by the mass of the second football player, this will in turn yield the velocity. But again, in this particular situation, because they're traveling in opposite directions and their final motion is at rest, the velocity has to be opposite that of the first football player, which was positive. So the velocity for the second football player has to be negative. So it's going to be a negative 6.49 meters per second. All right. Number 37 is easy. Okay. Number 37. A wall has a mass of a lot of mass, and the force is roughly 200 newtons. Okay. Is work done on the wall? And the answer to that is no. Work is not done on the wall. Excuse me. Work is equal to what? Force times distance. Excellent. The wall doesn't move. And because the wall doesn't move, no work is done. Distance is 0. So the answer to this is 0 work. Okay. Last but not least, our bike rider. I love the bike rider problem. Okay. What you have to understand about the bike rider problem is that at first, let's go ahead and scroll. I need to scroll here a little bit. What we have to understand about the bike rider problem is that you're dealing with energy here. You're dealing with velocity, and you're trying to figure out how high or how far up a hill vertically the bike rider is going to go. A couple things here. First of all, you need to recognize that you're dealing with kinetic energy initially. Okay, kinetic energy is equal to 1/2 mv squared. And this equation is provided for you on your equation sheet. But you're also dealing with height. You're talking about an object that's going up the hill, okay, with no friction, and they want you to find a height. Well, the only energy we really dealt with that deals with height is gravitational potential energy. So that's also going to play a role in here. So we go GPE is equal to mgh. Okay. Now, it says a bike rider approaches a hill at a speed of 5.20 meters per second. and coasts up the hill, which means that they're gaining kinetic energy right up to the point where they come to the hill, and then they let themselves coast up the hill, which means at that point in time, gravity takes over, and it's going to slow them down. Assuming there's no additional friction, which would be very hard to work with, at what height will the bike come to rest? So basically what we're looking at here is a conversion between kinetic energy and how much of that energy is going to carry them to what height up the hill. So really, the energy that they start with, kinetic, will be completely converted to the gravitational potential energy entirely. It's 100% conversion. So we can find the kinetic energy before, set it equal to gravitational potential energy, and then work out the things we know to find height. So let's go ahead and do this. I'm going to start by just setting the equations equal to each other. Okay, so walking through this step by step, 1/2 mv squared is equal to, in this problem, mgh. Okay, 1/2 mv squared is equal to mgh. And one of the unique things about this particular equation is that the mass becomes negligible, because both kinetic energy and gravitational potential energy have mass. So the mass actually goes away entirely. All right, now, you really have now v squared over 2 equals gh. And in order to isolate that h variable, because that is what we're trying to find, we're going to go ahead and divide both sides by g. So you basically end up with a very simple equation, v squared over 2g equals h. Now you just plug in literally velocity and gravity, and you can find how high the person will go up the hill vertically. So we say h is equal to 5.2 meters per second squared, because we're squaring that velocity, over 2 times gravity, 9.8 meters per second squared. And when you calculate all of that out, okay, you get 1.38 meters. Now, if you're not comfortable with all the algebra work of this problem, you can find kinetic energy individually, find a value, then set gravitational potential energy equal to that, okay, and then solve that way as well. It's a few more steps, but will provide and yield exactly the same answer, right down to like 6 or 7 decimal places. So long as you don't do a whole lot of rounding in there, you'll be fine. All right, these are the mathematical problems for the final review. If you have any questions, go ahead and email me. Thank you for watching.